last table problem here. We're looking at a pot of tea that is cooling. It says the temperature of the tea is modeled by the differentiable function between 0 and 10. The temperature is measured in Celsius. A, use the data in the table to approximate the rate at which the temperature of the tea is changing at time t equals 3.5. So notice on this one, they didn't, it's the same question that they've been asking. They just phrase it in words instead of in symbolic notation, which is something you've got to know the different representations. You've got to be able to look at it in symbolic terms. You've got to be able to look at it in word form. You've got to be able to look at it in a graph, in a table, in an equation. You got to be able to be familiar with it in all those different contexts. So at 3.5, well, our only choice here, 2 and 5, saying which the 3.5. So it's kind of weird. We're used to it kind of being in the middle of two values, but that's, I mean, it's just not directly in the, well, it is directly in the middle. I'm sorry. That is directly in the middle of 5 and 2. We're just not used to it being a decimal, right? So this can be approximated by h of 5 minus h of 2 over 5 minus 2, which is 52 minus 60. This one is calculator active, so if you're working it out, to be honest, you know, I'd use my calculator just to make sure you don't make that mistake there. So it is negative 2.667 degrees Celsius per minute. Remember, always include units, even if they don't explicitly say to. It never hurts to put units. This one just says show the computations. But it's still just 1 point for the answer, but you do have to have the work to back it up. Okay, you do have to have the setup to get that point, but it is only 1 point. So it could be, using correct units, explain the meaning of 1 over 10, integral from 0 to 10. What is that? That's average value. And what value we're talking about? We're talking about the temperature. So 1 over 10, integral from 0 to 10 of h of t dt is the average temperature, but it says use a trapezoidal sum with 4 subintervals indicated by the table. Okay, so remember, trapezoidal area of a trapezoid is 1/2 times base 1 plus base 2 times the height. So remember, we put that 1/2 right in front of everything. Don't lose the 1/10 either. So you got the 1/10, then the 1/2 for the formula. And then let's look at the table. Okay, it wants 4 subintervals, so we've got 1, 2, 3, 4. So this one's width 2, this one's width 3, this one's width 4, this one's width 1. Sorry, room up there. And then the temperatures, remember, are our heights, or excuse me, our bases. So that first one is width 2, and the base 1 is 66, base 2 is 60. The second one's width 3, base 1 is 60, base 2 is 52. Width 4, 52 plus 44. And width 1, 44 plus 43. Again, it's calculator active, so at that point, I'm letting the calculator take over. You gotta show the setup. You always have to show the setup on these. And then you put the answer, okay? And then let's explain it. It asks what it is, so is the average temperature of the pot of tea over the 10 minutes. Okay, so 1 point for your meaning, technically because it doesn't say explain it in the context, it just says using correct units, explain the meaning of that. So they explained it first and then they calculated it. I really don't think it matters. As long as you put those units of degrees Celsius in there and have that word average temperature. Okay, and you get 1 point for your setup and 1 point for your estimate. All right, part C. Part C says evaluate the integral from 0 to 10 of h prime of t dt. So again, at least write this down. And don't erase it, even if you don't know what to do from there. But remember, integral of a derivative. They cancel out, but you plug in your limits in these problems. Okay, so h of 10 minus h of 0, which is 43 minus 66, and that's negative 23. So using correct units to explain the meaning of the expression. So what are we doing? We're accumulating. H of t represents the temperature. So h prime would be the rate of the temperature change. And we're accumulating that temperature change. So the result is going to be the amount of the temperature change. So since it's negative, we can say the temperature of the pot of tea dropped or decreased. I'm going to say decreased. I like using the more mathematical terms. Decreased by 23 degrees Celsius over the 10 minutes. You get 1 point for the negative 23 up here and 1 point for explaining that that's talking about the temperature, the change in the temperature, whether it decreased or if it were positive, then that temperature would have, of course, increased. All right, part D. At time t equals 0, biscuits with temperature 100 degrees Celsius were removed from an oven. The temperature of the biscuits at time t, they give us a function for that, for the rate. Notice it's B prime. So that's the rate at which the temperature is changing. Using the given models at time t equals 10, how much cooler are the biscuits than the tea? So, let's find the temperature of the biscuits at time 10. Well, that would be equal to its initial temperature, and that's not a negative 100. I accidentally just did it. Okay, that would be started at 100 degrees. Plus, we have to add the integral of the rate over the time. Okay, from time equals 0 when it's 100 degrees Celsius to time 10. And we're going to use our calculator to work that out. So we've got 100 plus the integral of our function, which is negative 13.84 e to the negative 0.173x, comma x, comma 0, comma 10. And it gives us 34.182. We'll stop there. Okay, so that's the temperature of the biscuits. The T at time 10 is what? 43. So 43 minus the 34.182. 8.817. Remember, always 3 decimals. 8.817. Understand? Yeah. Okay. So we need to write in words. The biscuits are 8.817 degrees Celsius cooler than the t at t equals 10 minutes. Okay, so you get 1 point for this integral. You get 1 point for using the initial condition. And you get 1 point for your answer of 8.817 degrees Celsius.